Question 9 says a circus performer stretches a tightrope between two towers. He strikes one end of the rope and sends a wave along it toward the other tower. He notes that it takes the wave 0.885 seconds to reach the opposite tower 20 meters away. If a 1 meter length of the rope has a mass of 0.36 kilograms, find the tension in the tightrope. Now in Chapter 13 on page 388 of the Saraway College Physics book, it gives us an equation and it tells us we can't show you how we came up with this equation without calculus. And here's the equation. It says that the velocity is equal to the square root of the force, which the force being the force of tension, so divided by mu. Now what is mu? Mu, the Greek letter mu in this case stands for the linear density is what it calls it. So the linear density means how much mass per unit of length. So we find that by dividing the mass by the unit of length. And that will give us the linear density. Well, it tells us in a 1 meter unit of length, there is a mass of 0.36 kilograms. And so our linear density is 0.36. Now this particular problem wants us to solve for the tension, or the what we're saying is the force or the tension. And so we have to know what the velocity is, and we have to know what this linear density is. So the velocity, it tells us that this guy strikes one end of this rope, and it takes it 0.885 seconds to travel 20 meters. So our velocity is our change in x over time, or the change in x being 20 meters and the time being 0.885. And so our velocity is equal to 22.59 meters per second. Okay, so I'm going to move some of this out of the way. And what we're going to do is we're going to rewrite our equation. So our equation is that the velocity is equal to the square root of the tension or the force divided by the linear density. And so we want to solve for the velocity, so we can square both sides, and we get that the velocity, or we want to solve for the tension, so the velocity squared is equal to the tension over the linear density. And then we can multiply the linear density to both sides, so the linear density times the velocity squared is equal to the tension. And so that's our equation. We said that the linear density was 0.360, and we said that the velocity is 22.59, and we're going to square that value. And so you can plug those numbers into a calculator. You should get 183.85 newtons. Now with that answer, what I would like to do is show you how dimensional analysis gives us a clue that we're doing things right. So we say that the velocity is equal to the square root of the force over the linear density. And like I said, the book tells us, hey, we can't show you how this works without calculus. But we can show you that the dimensional analysis works. So one way you can check to see if your equation is right is through dimensional analysis. And so velocity has units of meters over seconds. And so whenever we take the square root of force, so force has units of kilograms times meters per second squared. And then this linear density we said is equal to the mass. So kilograms over length, or meters. So kilograms over meters. And so what we get whenever we have force over linear density, this is saying kilograms times meters per second squared over kilograms per meter. And when you divide by a fraction, like we're doing here, when you divide by a fraction, it's the same as multiplying by the inverse. And so we could say that kilograms times meters per second squared multiplied by meters over kilograms, and what we get is the kilograms cancel out, and then we're left with our units of meters squared over seconds squared. So we're left with the square root of meters squared over seconds squared, and so when you square root that, you're left with meters per second. So velocity is in units of meters per second. Whenever our dimensional analysis works out, that tells us that we could be right. You do dimensional analysis to see to make sure that you could be, because if this doesn't work out, then you can't be right. But as long as the dimensional analysis does work out, then you have a chance that you are right. It doesn't prove that it's right, but it says you have a chance that it's right.